Hello guys, welcome back. I hope you are doing great. In this video, I will show you how you can chat with any document. Let's say you have a folder and inside the folder you have different file formats. Let's say you have PDF file, you have text file, you have readme file and all these things. I will show you quickly how you can take all of your data, split the data into different chunks, do the embeddings using the OpenAI embeddings, store that into the Pinecone vector store. And then when you ask some questions, it can do the semantic search and get the relevant chunks, pass that chunk into the large language model and get the response. And at the end, I will also show you how you can have a simple chat UI, which will be similar to ChatGPT, but for your data. Let's get started. Okay, so now first thing first, we need to actually set up the environment, right? I will be actually providing different links as I go in the notebook. You can refer to those documentations for further understanding. But we need to first set up the environment. For that, you need to install the packages as normal. I have already done this, and then you need to import the things. And then you need to pass the chat OpenAI API key. Once you are done with this part, then we need to go and take the document loader from LangChain. There is actually many document loaders. As you can see here, there are many document loaders and the list keeps on increasing, and many people want to create the applications out of LangChain. In my case, I'm going to use the directory loader, meaning that whatever you have in a directory or a folder, we can load all of the files into the directory loader. Here I'm importing the directory loader from the document loaders. And here I'm passing the PDF loader, readme loader, and the text. I have already uploaded some documents here inside the document. So you need to actually create a folder here called documents and then upload the file and get the path of this. And then you can pass here, and you need to, if there is a PDF, you can do with .pdf, .readme file means MD, markdown, and TXT file meaning the text file, of course, right? If I run this command, now all of these files are being loaded in their respective loader. What I can do now is just create a list out of it, and then let's create the document from there, because we have the three loaders, but we need to create a document, right? This is the first part, like we are having our documents ready for the application. If I run this command here, it should load the loaders. And now if I just run this particular shell here, it should show us that there should be 3 documents, of course, and each document, there are 10,701 characters in your document. If I just want to print what is in the first document, it is about the GPT for all paper, so you can see it is related to the GPT for all paper. Similarly, you can print the documents 1 and documents 2. Now let's scroll down here. The next part, as I saw in the document, this is the next part, is now making different chunks of the data, because the OpenAI token limit, there is some limit in the tokens, and for that also we can just go to this part now. So what I can do here is, by the way, if you want to know more about the OpenAI token limits, I have provided the link on the top of this file. Just click this. I can show you, of course. And here there are the different max tokens for GPT-4, GPT 3.5, and so on. I don't have GPT-4 SS8. I'm using the GPT 3.5 for this demonstration purpose. Now let's scroll down to our page. Here I'm just saying the character text splitter. And now I'm actually passing the chunk size as 1000 and overlap 40, because it seems that if we pass some overlap, it performs better. You can just play around with this number. It all depends upon you, what kind of applications you want to develop. And here is the documents, and I pass the text splitter.split documents, and I pass the documents that we just created up, right? If I run this command, so now those 3 documents are now splitted into 23 different documents, or the chunks, right? Now we completed this chunk part. Now what next? If you just want to print, you can just print this document 0 and document 1 and so on. You can see it is printed here. Now comes the embedding part. By the way, this is just one line of code because we are using the OpenAI embeddings. So we just said embeddings equals to OpenAI embeddings. Now we just created we just instantiate the OpenAI embeddings. So now we need to pass that, right? So here is the 2 examples. If you want to go with the Chroma vector store is fine. I have just shown you the example here how you can do this, but I will show you actually how you can do this in Pinecone. Why Pinecone? Because when you run this OpenAI embeddings, it will cost some amount for you. And the good part of Pinecone is that once you have that embeddings is stored in the Pinecone, you can just retrieve that embeddings later on. You don't need to run all the time. Now, as I said before, if you want to go with just the Chroma, you can just run these two shells here. I'm not going to run this. I will just close this now here. Now we will go and see how we can do the vector storing part with Pinecone. Using Pinecone for storing the vectors, right? First thing first, you need to install the Pinecone client. Just run this shell, and I have provided on all the links here how you can do this. There are some of the documentations, what is vector store and all the different things. And by the way, I can just go here and remove this part so that the document looks fine. And what I need to do now is take the Pinecone API keys, because that is what we need. For that, you can just go to this app.pinecone.io and then just take the API keys and the environment. Just to show you what it is, I have already logged into the system, but I will just show you where you can get. If you click that and you need to go to the API keys, just copy this API key here and just come back to here, and we are using get pass for simplicity here. I can just run this shell. It will ask to input something. I will paste that, enter, and then there is the Pinecone API key. By the way, this is the good idea if you don't want to show your API keys, and it's secure way to do it. Now I also need to have the Pinecone environment. Although this is not that secure, I can just copy it from here because this is just the environment. But anyway, here I will just run this, and then now I have the both of the API key and the environment, right? Now I need to initialize the Pinecone. So if you follow step by step, it's quite straightforward, but many people find it confusing. I'm going step by step just to explain you. So now you need to import Pinecone in pinecone.init and pass the API keys, and then you need to have the index name. This one you need to first create it by yourself. If you go to the Pinecone part here in the index, I already have the LangChain demo index being created for me. But for you, what you can do is just go, or I can just actually delete this for you just to show you. What I will do here is LangChain demo, right? I will just delete this. It is going to be terminated, and I will create a new one now. Create new one, and this is how it will show you. You can just give LangChain anything you want, by the way, demo. And what is the dimensions? This is the good part, that we are using OpenAI. OpenAI has how many? 1536 dimensions. And you can just all leave this as it is, because Pinecone actually provide you one index free, so we can use it. You can just create the index. Now the index is being initialized for us. Once the Pinecone index is being initialized here, I will show you what we will be doing next. What we can do is just pass the index name that we just created, and just give the variable vector store pinecone.from documents, and we need to pass the documents that we just have the different chunks, right? How many chunks we have? We had actually 23 chunks, right? Meaning that we will have 23 different vectors being created in the Pinecone. I will show you how it works later. But just to show you, and that we need to pass the embeddings. We will be using the embeddings from OpenAI, as I said before, and the index name is just the index name that we are creating here. Let me see if it is being created. Okay, it is still initializing. And by the way, if you already have the index being created, as I said we can have the index being created and we can use it for later purpose, right? For that, what you need to do is you just need to pass the same thing as it shows here before, but pinecone.from existing index. Here, when we first initialize, we just pass from documents, but when you already have it, you can just run this from existing index. I could have just run this, but just to demonstrate how it works, I'm just showing you this. Okay, now it's ready, and if you see here, we don't have anything here, vector 0, right? If I actually run this command, because I need to create it, if I run this command, it will now create the index for us. Let's see when this finish running. It says, okay, retrying, don't worry, it will just pass. Okay, there is some error. What is the error? EOF end of line, but it is just a normal error. I think vector is to, if I again run this, it should actually pass. I don't know, for some reason sometimes it will create some issues. Okay, let me see. Okay, again there is some error and it is showing that SSL EOF error. I don't know what is this, but I think I can just run it again, because sometimes for some reason it has some error connecting to the Pinecone vector store from Google Colab. But I think, yeah, now it passes, as you see here. When this runs, if I go here and if I refresh the page now, there should be 23 different vectors being created. If I go to the index, yeah, there are 23 total vectors, right? That is the embeddings that we just have with the different chunks. The Pinecone part is now done, but this is not 19 because I had before different things. Here we have 23 documents and then we have 23 different vectors. Now that is all. Now we can start querying into our data. So just to show you how we can do that, that is the query. Who are the authors of GPT-4 for our paper? I can just say docs vector score, and then if I run this command, it will fetch the things. Now what it is doing, this is the main thing that you need to be really knowing what is happening here, right? So what we did, we had our data, we load with the directory loader from LangChain, we have the chunks, and then we did the embeddings and we passed that into the vector store, in our case Pinecone. That was already done. And then we have our user query. I just run that. What is happening behind the scene is that query is also converted to embeddings, because machines just understand the numbers, right? We need to convert that into the numbers. Embeddings in general is just converting the strings into the numbers. And then that embedding or the number will go to the Pinecone vector store and we'll find the similar one. As you can show here, we said that similarity search. So the thing that who are the authors of GPT-4 for all paper, that is going to convert it into the vectors, and that vector we will be searching in the Pinecone vector database that we have 23 different vectors, and it will find the most similar ones and it will provide us the answer. That is all what is happening here. So it will find the relevant data chunks and then it will pass into the LLM, and then we have the response. Here you can see we have the vector store, similarity search, and the query, but here we haven't passed through the LLM part. Now we are just in the vector store part, right? When I run this length of documents, it will show 4. It finds 4 of those vectors which has similar embeddings to this, who are the authors of GPT-4 paper. If you want to just print what is the page content, you can just print here. So as you can see here, there are the different authors name in this particular chunk, right? So similarly, you can go and query all the different documents. Now this is done. Now comes the LangChain part, where we will be creating the chain, and we also want to create in such a way that when we ask something to the chatbot, it will remember the history what we are also asking. Okay, now the LangChain part, as I said before. If I just expand this shell from langchain.llms, I'm going to have the OpenAI. By the way, there are many chains in LangChain actually. If I just click this, so chat over documents with chat history, you can go through this document for different kinds of chains. But here I'm just going to show you the conversational retrieval chain part. Here I'm just importing the OpenAI and the retriever, right? We need to retrieve from the vector store. What we did here, vector store dot as retriever, source type similarity, and the source query. We just want to have the k equals to 2, and QA is the question answer, and the conversational retrieval chain dot from LLM, right? And we pass the OpenAI temperature 0. You can just pass anything here, and the retriever, because this is the main part what we are doing now. As I said you before in the diagram, we have the user query, and then the embedding is already here. But when we pass that, we need to take these relevant chunks and pass into the LLM and get the response. right? That is all done in a simplest way with just one line of code with LangChain. So if I just run this command, OpenAI is not defined because I didn't run this shell before I run this. Okay, now it should be fine. Okay, now we have the chain, question answer chain, and now I just can ask the questions. Let me first have the chat history 0, right? How much is spent for training the GPT-4 for all model? And I can just pass the question as query and the chat history as chat history. Before I just have the empty string here, right? If I just run this command, it will show me that, okay, it is, let me see, 200, right? And the chat history dot append, now we need to append the query and the result answer. And if I just show you what it is here, it is being appending how much is the, how much is spent for training the GPT for all model, because that is the question I asked, and the answer is 200. So I am actually having the chat history, right? Now what I will do next is ask some different question. What is this number divided by 2, right? And then I will just ask the question as query. I'm passing the chat history, which also has the previous question and answer part, right? If I run this command, it should actually show me 100, but for some reason, as you can see, let me see what it says 400. So this is what you must be really careful, because large language models are really large, and it does not mean that everything will be correct. And as I said here, what is this number divided by 2? It remembers the history, but then instead of showing 100, it is showing 400. Yeah. And what if I just said that what is this number multiplied by 2? Let me see what it will show. Because as I said in my previous video also, you have to be really good with the prompting part. Okay, now it says 1600. Okay, but the good part here is that it remembers something, right? I haven't passed here anything about the paper or something like that, but the main part here is it knows the chat history so that we can have the conversations as we go. Okay, this is all, but if you want to have this in a small chat UI kind of things, let's go through that now. Create a chatbot with memory with simple widgets. I will just open this now. What you can run is from the IPython display, import display and IPy widgets as widgets. Here, as I said before, we need to have the chat history as a list, empty list in the beginning. And there is some function for the chat, and I can just run this command. If I run this cell, here it will be asked, I can ask the questions. This is just normal things. I can just say who are the, let me see, who are the authors of GPT for all paper, right? I can type enter, and then it will go through the vector search, vector store, find the relevant one, pass that information into the large language model and give us the answer. As you can see here, user, who are the authors of GPT-4 for all, and the chatbot replies, the authors of GPT for all are this, this, and this. So you get the answer. So follow-up questions you can ask which is related to this, but any things you want, because I'm passing actually here 3 different things, right? One is the PDF file, one is the README, and in the README I have passed the pandas-ai README. Let me ask something like that. What is pandas-ai, right? Because that was the video I created last video was about this, where you can have conversation with the tabular data with the help of pandas-ai. And it says here that pandas-ai is a Python library that adds generative artificial intelligence capabilities to pandas. You can see the power of this, that you can have any kind of documents, and with the help of LangChain you can just pass all the things and into the vector store and have a conversation with this. This can be done in an organization where you have many data, or not many data also, or many documents, and you need to query it with them. But one thing is that always be careful that you don't pass the sensitive information, although we don't pass the direct message to the OpenAI, because we are storing everything into the vector store, and we are just passing the question, and it will find the similar thing from the vector store, and that is passed to the LLM. But always be careful when you implement something, because we never know. Something can happen, something can be leaked. Always be careful when you create some kind of chatbots. Okay, this is fine, but if you want to go one step further, you can even create a Gradio UI. This is the UI already fine, but if you just want to have the Gradio UI, I have just provided the link here. You can go through the link. I have just actually copied the link from there, and for some reason it is not working here. I will just show you how it works before. This is just the code from Gradio. It is doing this is the example from Gradio. So what it is doing is just running the shell, and it will create an interactive UI kind of things if you prefer this way. And you can just ask something here, hello, and then it says I love you, because it is just providing you answers from these three different choices. And you can just pass hi, let's say hi again. It will just provide you among these three. It is working fine with this example, but I tried to incorporate this piece of code into our application, which I'm showing you here. Here I just have the same code, but instead of the random choices, I'm passing the conversational chain and the user message and chat history and all these things. But for some reason it is not working. And your task now is that I will provide the code in the GitHub. Just go through this. Let me know if you are able to achieve, or if you are able to run this code. What I'm showing you here is I can just say hello. It will run for the first time, right? And then it is also printing here, because I'm passing debug and share equals to debug equals to true, meaning that when you pass debug equals to true, it will just provide the print, all the things. Now if I go here and say who are the authors of GPT for all paper, it is going to show some error for me. And then it says that the unsupported chat history format list and all these things. I haven't been through the documentation and fixed this, but maybe you can do the task. Go through this notebook. As I said, I will provide this in the description of this video, and let me know and let others know in the comment section if you were able to solve this. Yeah, this is all I want to show you in this video. I think although this is quite complicated kind of things when you see on the high level, but with the help of LangChain, you can actually easily achieve these things. And now you are not restricted only to PDF or with the tabular data or different things. You can have different kinds of file formats. Just take that into the directory with the LangChain, with the document loader, make it into different chunks, do the embedding part, load that into the vector store, query with some questions. It will do the similarity search, pass that relevant data chunks into the large language model, and then you get the response. Yeah, there are many pieces, but when we join that together, it seems really simple. Yeah, I hope you like this video. Thank you for watching, and see you in the next one.